Welcome everyone to the presentation on radar, which is a powerful analytical equipment. Myself Prem, I'll walk I'll walk with you through the principles, types, and application of radar, groundbreaking technology with immense significance across the various fields. So what I'm going to cover in this video and why I choose the radar, what is the principle, what is the types, what are the interference it has and advantages and limitation. Also, what are the uses of radar in chemical engineering we are going to see in this uh, video. So why I choose the radar? That because it has interdisciplinary relevance, the technological enhancement it has vast use in real life application, research that are possible in the future, nearby future, along with the important it has in the safety and the security and its uses, which can be very important. So what is the radar? So this radar acronym stands for radio detection and ranging. So this uses electromagnetic waves for detections. In early 1930s, Sir Robert Watson and Watt uh, and other developed the practical model for radar systems. During the World War One, the radar was in the initial phase of testing. During the World War Two, it seen the rapid growth and it was being extremely used and extensively used for air defense and naval purposes. So after the war is over, radar find its application in various sectors like medical and engineering. So what is the principle of radar? So radar operates based on a simple principle which includes transmission of electromagnetic waves which travel through the space, interact with the target and reflect back as it goes. The process begin with the transmitter generating the waves. The radar receiver capture the returning radar receiver capture the returning echoes and analyze the time delay to calculate the distance. So this is a animation describing the basic principle of radar. Includes transmission and reception, and between that it note the time between the process for the process. So the principle, as I already discussed, they include transmission. It has transmitter for transmission. Then happen the transmission of signal, then target interaction, then the reception of echo. So what is the echo? That known as the reflected signal, which is known as echo. Uh, Also, there is a receiver for reception of echo, uh, and then the time measurement is happen is done that the radar measure the time delay between the transmission of the signal and the reception of echo. This interval is used to calculate the distance to target using the formula which is distance is equals to speed of light multiplied by time delay divided by 2. So radar system employ various antennas, uh, including a reflector type and arrays type, uh, each suited for a specific application. This antenna focus and direct the transmitter waves while the receiving reflected signals with precision. So antenna is an important component of the radar system. How is the measurement done? As I already discussed in the principle, how is the distance determined? The Then the target direction is determined by the radar antenna orientation. By rotating the antenna and identifying the angle where the reflected signal is strongest, the radar calculates the bearing or azimuthal angle of the target. Then the elevation angle is the angle formed between the radar's horizontal plane and the line of sight to a target. This measurement is crucial for calculating the target's altitude. particularly in the applications such as air traffic control or missile tracking. Coming to the range resolution is the radar's capability to differentiate between the two or more targets locations close to each other. It is influenced by the pulse width of the transmitted signal, with the narrow pulses providing the better resolution and the clear target separation. You can see these animations. Here it comes radar classification. Radar is basically majorly classified as primary and secondary. So primary is then classified into continuous wave and pulse wave based on the signals uh, we are emitting. So continuous wave uses continuous electromagnetic signals, unlike pulse input signals in pulse radar. So continuous wave are further classified into modulated radar and unmodulated radar, while pulse are then classified into MTI radar and Doppler radar. Coming on primary radar is a radar system that detects object by transmitting radio waves and receiving the reflected signals, which is echoes. It works on the fundamental principle of emitting electromagnetic pulse and measure the time it takes to the signal to return after bouncing to the target. So the key features of primary radar are passive target detection, object detection, and range measurement. No identification information is there. So the further classification of the continuous wave radar is that it classified into modulated radar and unmodulated radar. So modulated radar uses a modulated signal to measure the distance by distance and speed more accurately, while unmodulated radar transmit a continuous signal without modulation, primarily used for speed detection. While pulse radars are classified into MTI radar and Doppler radar, MTI radar differentiates between moving and stationary objects by analyzing the Doppler effect, while the Doppler radar measure the frequency shift caused by the movement of the target to calculate its velocity. So here it is a block diagram of continuous wave radar. So it includes the component of transmitter, which generates the continuous wave signal at specific frequency. Typically an oscillator like crystal oscillator is used to produce stable signals. Then it has antennas, a signal separator. Antenna is used for transmitting and receiving the signals. The transmitted wave interacts with the target and reflected back to the radar. So there is a receiver that receives the reflected signals echo from the target. If the target is moving, the reflected signal has a frequency shift due to the Doppler effect. Then it comes to the mixer, combine the transmitted signal with the received signal to extract the Doppler frequency. The output of the mixer is difference between the transmitted and the receiver frequencies proportional to the target velocities. Then it comes to amplifier. Amplifier amplifies the Doppler signal for better processing, ensuring the signal strength is sufficient to accurate measurements. Modern systems use digital signal processor for the enhancement of accuracy. There is display units present information such as target speed or velocity in the table format, and often includes visual indicators or numerical readouts. So what is the Doppler effect? The Doppler effect refers to the change in the frequency of a wave when there is a relative motion between the source and the wave and an observer. In context of our radar, when a target moves towards the radar, the frequency of the reflected signal compression of waves. When a target moves away, the frequency decreases, which is stretching of waves. This frequency shift helps us to calculate the velocity of the moving target. So this is the block diagram for pulse radar. So pulse radar operates by transmitting a short duration electromagnetic pulse, and when then waiting for the echoes to return after reflecting from a target. This helps to determine both the range and velocity of the target. Uh, Here is the explanation of its block diagram. Transmitter which generate high power short duration pulses of electromagnetic waves. The pulse width determines the radar range resolutions. Then pulse modulator are there. which controls the transmitter to produce pulses at specific intervals, which is pulse repetition frequency or called PRF, which is ensure precise timing for the signal generation. Then there is the antenna which radiates the transmitted pulses and capture the reflected signals, which is echoes from the target. Often a single antenna is used for both transmitting and receiving with a duplexer switching between two modes. So duplexer is a switch that alternates between the transmitter and the receivers, and it protects the receiver from high power pulse during the transmission. Then it is receiver which amplifies and process the weak reflected signals receiving by the antenna and extract the information like amplitude, time delay and frequency shift. Then it comes to the signal processor, which converts the time delay of the received echo into the range of the target, process Doppler shift to calculate the velocity of the moving target. Then it is goes to the amplifier, which amplify the signals, and then it is converted to the data, uh, and which is fed to the computer. Here we can see that on the slide, the primary radar is extensively used in the meteorological purposes and by the police and security systems for calculating the velocity. So while pulse radars are majorly used for the range and velocity targets, while the CW radars are only used for velocity and not that much for the range. The secondary radar system rely on the transporter installed on the target, which relies on the radar signal with additional data such as identification codes. This systems is commonly used in air traffic control to communicate with the aircraft. It has key feature of like identifying the targets, higher accuracy, and long range detection. So secondary radar has extensive use in air traffic control and in military purposes. These are used frequently. So the frequency bands in the radars are essential as they define the range of the frequency used for signal transmission and reception. Different frequency bands are utilized depending on the application, such as unique propagation characteristic, resolution, and range capabilities. Like high frequency HF, 3 to 30 megahertz is used for long range communication. There is VHF, UHF, L band, S band, and all of this many more things according to the uses of individual bands. So this is the mathematical equation for finding the power back to the antenna. So here is the equation. PT is the power transmitted by the radar. GT is the gain of the radar transmitted antenna. R is the distance from the radar to the target. Sigma is the radar cross section between the target. A effective is the effective area of radar receiving antenna, while the PR is the power received back from the target by the radar. So this is the simplified form of radar equation. Antenna theory gives the relationship between the transmitting gain and the receiving effective area of the antenna, which is G is equals to 4 pi AE divided by lambda square. So since the radar generally use the same for antenna for both transmission and the reception, we can obtain the two other forms of the radar equation, which is given as below, which is used to calculate for maximum range of the radar. For finding the maximum range of the radar, simplifying the radar equation, keeping all the other parameters constant, we get the relationship between the transmitting power and the range, which is R max is directly proportional to the fourth root of the power emitted by the antenna. So here is the numerical on the finding the range, maximum range of the uh, radar. So you can go through this numerical. So how we calculate the maximum range of the radar, we can get to know by knowing the maximum maximum power emitted by the antenna. What are the interference for the radar? So noise, which is the random unwanted signal from the radar system or environment, reducing the signal clarity. Then there are the clutters, which are the unwanted echoes from the non-target object like terrain or weather. Managing using the Doppler filtering and clutter rejection techniques. The third one is the jamming, which is deliberate interference to disrupt the radar detection, countered with frequency hooping and anti-jamming methods. So here we go through the advantages of radar. So radar has many advantages compared to an attempt to visual observation. So radar is able to operate day or night in lightness or darkness over the long range. So radar is able to operate in all weathers, in fog and rain. It can even penetrate walls or layers of snow. Radar, it has very broad coverages. It is possible to observe the whole hemisphere. Radar detects and tracks objects that are moving. High resolution imaging is possible that results in an object recognition. Radar operate unmanned 24 hours a day and 7 days a week. So with the lot of advantages radar has, it has many shortages also. Like the cost is very high, and acquisition and maintenance expenses would be very costly. Again, the environmental interference, which we have already discussed in noise, uh, which can intervene in your signal attenuation in heavy rain or snow. So there is a limited resolution also. You can say that size and portability, which is also a big factor for installation. Also, the power consumption is very high for the radar systems. So detection limitations are also there. The new stealth technologies which can evade the detections, and signal processing complexity is also there. You require advanced algorithm and expertise for the signal processing. So radar has an various application in all the field, in the interdisciplinary fields. But coming on our chemical engineering, it is very useful in level measurements, which is non-contact radar level meters are used for measuring the height in the tanks, in the reactors, especially for the volatile and corrosive substance, ensuring the accurate inventory management and process control. This non-contact radar also help to uh, measure the accurate flows. Also, there are flow measurements which can be uh, very accurate because there is no contact between it, so no losses will be there. And safety and leak detection, it will be give you a precise result for the safety and leak. So there are many more detection there will be there. So that's all about the radar. Thank you for watching this video.